Introduction to Computers, Wednesday. Believe it? Of course you do. Week 14, day 38. If you can read that. Week 14, day 38. Here we go. Talk about programming today. We have just a few terms we'd like people to distinguish with programming and understanding a little bit of how it works. And then database. I do another basics, assignment 5. We look at the results, talk about starting the project, and then they do group work. So let's coding. I did mention if anybody wants to come to a speaker, but that's already occurred by the time of this recording. Okay, coding. Humans write code. Okay, we write code to solve a problem. I can put an asterisk by it, how important that is. And before we solve it, we can design a solution. You can design a solution using pseudocode, false code. Look, you can put together all this text to show how a program might work. Or you can draw a picture, flowcharts. We'll look at flowchart examples on Friday. So, to understand the difference here, this would be more text-based. It would read more like a recipe. This is like a diagram. Whoops. Let me back up there. This is like a diagram. This is a map of how to solve the problem, and this would be a list of how to solve the problem, so to speak. Alright. And then we talked about code. It's done in a programming language. And the students rattled off lots of programming languages. Python, Java, C#, C++, Visual Basic. And I rattled off a few old ones from the old days. Fortran, COBOL, Pascal. Formula translators, more for scientific type work. COBOL, Common Business Oriented Language for businesses. Pascal, well, Pascal stands for the person Pascal, the famous mathematician, programming language named after him. So, let's take a look at what happens when we write code. Code in one of these languages that we have listed here, and there are hundreds, so not necessarily those, but we write it in a language, some source code. The language. Usually these are referred to as up here as a high level language. There's a middle and low level, but we're going to cover that here. Then the program that you write, then it gets either compiled or interpreted. Okay? Interpreted means it's converted when you run it. Compile means you compile it and then you run the executable. Okay? When you do either one of those, they are done based on the system you're going to run it on. So which operating system you're going to run it on. So you could compile, you could write some source code and compile it to run on Windows. Or you can compile it to run on Linux. You could compile it to run on an Android. You could compile it to run on an Apple, iOS. Okay. Once you compile it, then you get an object code. And this is code that the computer can understand, humans don't. So we have humans up here, computer here. And there's a lot of code to do specific things that we don't have to rewrite, so we can take this other code and link it with the object code, and then we get an executable. And that's what the computer executes an executable. So you can compile it so it's an executable, Or you can run an interpreter so it creates an executable while you run it. I gave an example. Graveball. Graveball is being designed, a lot of the code is written in C++ with Unreal Engine. It's designed to run on Windows. But he's going to be able to compile it so that it'll also run on an Xbox, and we're not even at a PS2 anymore. It's like PS4, but PlayStation, Xbox. So you would just compile it using a different compiler, and you have to make some adjustments and so forth, and then it'll run on a different operating system. Keywords, right? Source code, object code, executable code. Compile software. And this is how it works, basically. All the software we have in the world, that way. That's what happens. Okay, next thing I'm going to do, talk a little bit more about databases. This idea of a flat file, like all these files in a filing cabinet. Okay, you might put ones in different drawers, but we gathered records or information about people or things or events, right? If you ever think about that, we store data. You know, we sometimes store data on a thing. You know, it's like storing inventory. We might store an event, like something that occurred. Okay. We store things about people, information about people, or courses, and so forth. Some information is more static, and some is more changes. This flat file system doesn't work as we start to get lots of data. It'd be like if you tried to store all your data in a spreadsheet, eventually it would get too big, too cumbersome to manage it. If you had hundreds of records, hundreds of fields, let me say, hundreds of fields about a specific thing, like all the things you could store about a human. So then they said, well, let's just create tables and relate those together. So we create entities. Okay? So let's use an example you may have used, or you may have not. Redbox. Here. Let's put some red around that. Now we have Redbox, where you rent the videos. Okay? So you got the videos. Now you can rent other things, but we're just going to focus on videos. You got a video ID and then all the information about the videos. That's an entity. Then we have users, or you might refer to them as customers. You know, customer ID, all kinds of information about a customer. Not a lot, probably. Probably just store their phone number, email. You really don't need to know where they live. You don't need a whole lot. And then we have the checkout process. Okay? So we put in a customer ID and a video ID and when it's due. Let's look at that. So I got customer here, and so this customer here checks out the video here, so they check out this video here, and then we have a due date. Alright. And so then we can just list them, list these records. Okay, we bring the video back, it takes the record out. We run another video, puts a new record in. So this entity changes often, whereas these two entities tend to stay more static. Okay? So it's good. These tables don't change much. This one changes all the time. So, one more example of relational databases. Okay, and that's it for today.